Welcome back to the next video. In today's video we will be learning about pointers in C++. So what basically are pointers? Like pointers are those kind of variables which are used to store address of another variable. And why would we use pointers? So basically what I have noticed, like I am still a beginner in C++, but suppose there is a function which takes a value. Suppose it takes an input as string, but instead of passing that input directly as a string, you can pass pointer to that particular string. So this is something called pass by reference, and it helps us to easily optimize our code. So that's the general view of it. There are more to pointers as well, but I'm keeping it pretty simple. So firstly we'll see one example over here. So I'll just uncomment this out. So here what I'm doing is that I'm declaring a pointer of type int. So this star thing which you see is that means that this is a pointer. Now this star can be over here, it can be sometimes like this, or it can be like this as well. Okay, all these these three things are the same thing. So basically most people use something like this. So this is a pointer which can store address of another int data type. So this is a pointer of double, but it can store address of another variable of type double. Now you can also initialize your pointer to be a null pointer by default. So here you can see this is null pointer. This is as good as, like, you might be little confused with this curly brackets, like it is as good as saying something like this. Okay, so don't get confused by this curly brackets. This and this were the same thing. Like if you write something like this, or if you write something like this, both are the same things. Okay, so these are a pointer, and here I'm just printing the size of our pointer as well as size of normal int. Similarly for double as well, I'm doing the same thing, and here again same thing. I'm printing size of our pointer, but here I have initialized it as null pointer. So let's just see what it prints out. So mostly it would be the same, like whatever it would be the size of your int and the pointer would be same. But in some cases, like given how complex C++ is, here you can see the size of number pointer is 8, but the size of int is 4. Even though both are of type int, in this, like, it depends on version to like on which OS you are on, which C++ version you are on, those kind of stuff. Like even I am don't have clear picture on that, but yeah, but basically they are the same, like size of pointer and size of your data type, like a normal data type, but they can vary as you can see over here. But for a double they are same, the size of the pointer as well as the size of normal double. Similarly for null pointer as well. Okay, now I will just comment this out. I'll run a second bit of code over here. So you can see that I have defined a normal variable of type int, then I have defined a pointer which takes the address of int underscore var. So this ampersand which you see, it means that we are assigning the address of variable int underscore var to this pointer p underscore int. And here what I'm doing is I'm just printing the value of 43 of int underscore var, which will be 43, and here I'm printing the address. Okay, the address of int underscore var. Next again I have defined another variable which is equal to 65 of type int, and here I have changed the value of int underscore var equal to 126. Okay, and here what I'm doing, I'm again taking the pointer and I'm assigning the address of int underscore var to p underscore int. So here now our pointer is storing address of this particular variable, and so if you want to print the address, we can use something like this. Now you can also get the actual value from your pointer as well. So for that you have to use something called dereferencing, and it is as good as adding an asterisk or a star to your pointer. So I'll just run this, and here you should see. So here you can see this is 43. Okay, then this is printing the address of int underscore var. Next we are assigning our pointer to int underscore var 1, and here you can see it is printing the address for this particular variable, and once we dereference it, it prints this actual value because this was the latest stored in our pointer. Okay, next is we'll see it for characters. So characters is also pretty much the same. So here I have created a pointer which is pointing to null pointer at the start. Then I have created a character which has a value of a. Then I am assigning the address of our character to our pointer. Once we get the address, we are dereferencing it to print the actual value. So we are dereferencing our pointer to print the actual value. So here it will not print the memory address, but it will print a. Now I have taken another variable and of type data type character, and here I am assigning it to our pointer. Again I am assigning the address, and here again I am trying to dereference it. So here it will print c. So I will just quickly run this. So here you can see it is printing a, then it is printing c. Okay, next we'll see pointer pointing to const state data. So this this is now the tricky part will start. So just comment this out. Okay, so here I have one variable. Now here I am assigning const before our data type, but this is a pointer. Okay, and it is storing address of number 3. So what this means is, if you assign a const before the data type, is you can point to different address, but you cannot change the value of the pointer directly, but you can change the value of the variable it's pointed. So here you can see we can't change the value directly of our pointer. It is giving compiler issue. So I'll uncomment this, but I can change the value of number 3 because it is not const, even though our pointer is referencing to this number 3. So I can easily change the value of number 3. And here you can see I have defined another variable, but I can also change the address of our pointer. So here you can see I am pointing to p underscore number 3 equal to address of number 4. Also over here what I have done is I have defined another variable and another pointer, and it takes the address of this particular protected underscore var int data type variable. Okay, and here you can change the value of this, but again you can't change the value of this. You can assign it to different address if you want to, but you can't directly dereference and assign the value to it because it is of type const. If it wasn't const, suppose if this wasn't const, then you can do something like this, then this is valid. Okay, but I'll keep it as const. Now if I try to print this value, so protected var will be 10. Okay, okay, then this is p protected var, right? I think I made a mistake over here. This should be p protected var, and here we are dereferencing the value. So basically what according to my understanding is this should be 66, and this should be the memory address, and this should also be 66. So let's run it. So here you can see it is 66, this is memory address, this is 66. Okay, so this is done. Let's see another example. So I quickly uncomment this. This is little bit not little bit, this is very confusing. Even I don't remember it. Like tomorrow I will forget this stuff. So yeah, that's why C++ is very tough. So here I have defined a variable of type int. Then I have assigned const to both our pointer as well as to our variable or data type. So what this means that you can not change the value or the address. So here you can change the value of this because this is not a pointer and it does not have const as a keyword attached to it. But if you try to do something like this, this will give you a compiler. If you try to dereference it and change the value of your pointer, it will give you compile time error. So I'll quickly run this and show it to you. So here you can see it value is 12. Okay, and here you can see this is pointing to memory address, and this value is also becoming 12. Okay, because this value changed. Even though we are not reassigning it, we don't need to, because it is already pointing our pointer to the memory address of new underscore var. So if this changes, the dereferencing value also changes in this particular pointer. So I'll quickly comment this out as well. Next Here I have another type. Here I am assigning const to our particular variable but not to the pointer. So that means here you can't like you can change the value but not the address. So here you can see this was giving compiler issue, that's why I have uncommented out. So here once I have assigned this particular variable's address, you can't really change it. You can dereference the value of it so 30. So if you see here, new var2 will print 30, even though we haven't directly manipulated it, we have manipulated it via pointer. Here this will print memory address of new var2, and this dereferencing will also print 30. Okay, so let's see this. So here you can see 30 address, again 30. So yeah, that's it. Thank you for watching. Bye.